State the most specific name for each figure. All right, we've got 4 of them here. They're all quadrilaterals, but I could probably be a little bit more specific for each of them. For example, we have a quadrilateral where 2 opposing sides are parallel, and that's it. That's all I've got. This would be a trapezoid. Now, there's different types of trapezoids. There's a right trapezoid. That's if you have a trapezoid that creates a right angle. That doesn't happen here. What's next? Well, we've got 1 pair of parallel sides. We've got 2 pairs of parallel sides. This would be a parallelogram. Parallelogram. Okay. This guy right here. Congruent, 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 congruent. Don't know anything about the angles. Don't know if they're parallel. But what I do know is all 4 sides are congruent, which means this would be a rhombus. A rhombus is what I took to school one time and went to a different place. Hee hee, joke. And then we have ourselves 4 right angles. Opposing sides are congruent and opposing sides are congruent. This is a rectangle. So a couple of the ones we didn't hit square. We didn't hit just a quadrilateral. We didn't hit kite. But, you know, I think those are pretty simple, pretty straightforward. Those are quadrilaterals. Fun. Find the measure of each angle indicated. All right, so it looks like in this case, I only have to find angle G. Now, what I have here is a 1, 2, 3, 4-sided figure, also known as a quadrilateral. The angles in a 4-sided figure add up to 360 degrees. I've been given 3 of those angles. So if the angles add up to 360 degrees, then 65 plus 110 plus 87 plus, I don't know, I'll call it X equals 360 degrees. Let's combine like terms one at a time. 175 plus 87 plus X equals 360. 175 plus 87, 262 in that order, or not in that order. Did I do that right? That looks good to me. Plus X equals 360. In order to get X all by itself, let's subtract 262 from both sides. X equals 98, but we will say 98 degrees. Okay, 0.6 away from a pretty popular boy band from the late 90s. Or was it just 98 degrees? I think it was just 98 degrees. Nick Lachey. Pretty famous guy. Look him up. Solve for X. All right. What we have here is 4 sides, so that whole thing is 360 degrees. Now, there's 2 ways that you can do this, but let's play dumb. Let's just say that all I know is I have 4 sides, which means everything adds up to 360 degrees. Okay, so 104 plus 10x minus 4 plus, interesting, 104 again, plus 76 equals 360 degrees. So if we combine like terms, I have 104 minus 4 is 100, plus 104 is 204, plus 76, 204 plus 76 is 280. And then I have plus 10x equals 360. 2-step problem, subtract 280. Subtract 280, 10x equals 80. Divide by 10, divide by 10, and x equals 8, which is all I had to do. Now, there's another way that you could do this problem. And let me show you that other way of doing this problem. Okay, if these guys are the same, right, that implies that these guys are also going to be the same. Because what we have here, actually, you know what? Since I'm not given any markings, I'm not definitively given that information. Although, yeah, it's got to be the case. If these guys are the same, then these guys have to be the same. They have to be. So I have 10x minus 4 equals 76. If I add 4, 10x equals 80. Divide by 10, and looky there. 10, 9, 8, 76ers. And two ways to do that problem. Both ways you'll get 8. 8, 8, 8 is great. Solve for x, the figure is a parallelogram. Oh, this is nice. If the figure is a parallelogram, we know a couple things. These guys are parallel. These guys are parallel. Does that help us here? No. What else do we know? These guys are congruent. And most importantly, these guys are congruent, which means we could say 2x plus 15 is equal to x plus 15. Subtract x from both sides because we have x on both sides of the equal sign. 2x is minus 1x is just an x. X plus 15 equals 15. Subtract 15, subtract 15. You cancel out, and coincidentally, so do you. So x equals 0. And you might be thinking, no, that can't be right. You can't have 0 distance. Well, I'm not given the distance. X is not the distance. X is just some placeholder for these guys. If I were to replace x with 0, you disappear. And if I were to replace x with 0, you disappear. And you both end up being 15. So 0 is the correct answer because the math ends up the way it's supposed to. So that's how you do it. Solve for x, the figure is a parallelogram. All right, what do we have? We have two angles that are adjacent to each other. In parallelograms, if two angles are right next to each other, those angles add up to 180 degrees. Now, if they were opposite of each other, they would be congruent, but that's not what I have here. What I have is two angles that are next to each other, so they add up to 180. So 80 plus 11x minus 10 equals 180. Combine like terms, so 80 minus 100 minus 10 is 70. So 70 plus 11x equals 180. Subtract 70 from both sides. Subtract 70 from both sides because it's a two-stepper. 11x is equal to 110. In order to get x all by itself, divide both sides by 11, divide both sides by 11, and x equals 10. So that's how you do it. Okay, make sure in this case you set them up equal to 180, not set them equal to each other. Very easy to make that mistake. We didn't make it. So we got it right. The figure is a parallelogram. TE is 4 plus 2x. So what's TE? Your TE. You are 4 plus 2x. EV is 4x minus 4. Now, in a parallelogram, the diagonals bisect each other. In other words, UE will be congruent to ES. But most importantly for us, TE is congruent to EV. So the way I set this up is 4x minus 4, because EV, is congruent to TE, so equals 4 plus 2x. So I have a variable on both sides of the equal sign. So what I'll do is I'll subtract 2x from both sides minus 2x, cross u out. 4x minus 2x is 2x. Drop down the minus 4, drop down the equal sign, drop down the regular 4. 2x minus 4, let's get rid of the minus 4 by adding 4 to both sides, like so. 2x equals 8. Divide by 2, and x equals 4. So circle that and call it a day, right? Wrong, because it's not asking us to find x. It's asking us to find TE. TE is 4 plus 2x. X is 4. So TE is 4 plus 2 times 4. 2 times 4 is 8, like so. And 4 plus 8 is 12. And so TE, tight end, equals 12. A little football reference for you football heads. Speaking of football head, Hey Arnold, remember that show? Like and subscribe. Given parallelogram ABCD, I need to prove that AB, that one, is congruent to DC, that one, and AD is congruent to BC. This is one of those types of proofs where you want to look at this and say, well, isn't that the definition of parallelogram? So it's like a two-stepper? No, this is one of those things where we are trying to prove a theorem, and the theorem is parallelograms have opposite sides that are congruent. So we already know this. We just need to prove it. So what do we know? Well, it gives us these little markings here that tell us that they're parallel. So it says parallelogram, so we know that they're parallel. We know that they're parallel. And usually when they give you parallel information, you're thinking alternate interior angle thoughts. So I'm going to do this. I'm going to focus on AB and DC, and I'm going to say that these two guys are congruent because they're alternate interior angles. And I'm also going to say that these two guys are congruent for the same exact reason, alternate interior angles. Now, if I say that, and if I also say that AC is congruent to AC, then I have these two triangles are congruent to each other using ASA. And since ASA tells me that these guys are congruent triangles, that means these sides are congruent and these guys are congruent by CPCTC. Congruent parts of congruent triangles are congruent. No, corresponding parts of congruent triangles are congruent. Tough one. So that's what we're going to do. We're going to say, you guys are congruent, you guys are congruent, you guys are congruent, reflexive. Then we're going to say that the triangles are congruent. And then from there, we can do the proof by using CPCTC, and that should do it. So first things first, always the given. Okay, we are given a parallelogram ABCD, and that's our given. Now, this might be an unnecessary step, but there's no harm in doing it. Since it is a parallelogram, we will say that AB is parallel to DC. AB is parallel to DC. And I'll just say also that AD is parallel to BC. Okay, no harm in saying that. Didn't kill us. I'm still alive. That's the definition of parallelogram. Can I fit it in? I did. Barely. Looks sloppy, but I did. All right, now let's do our angles. Angle BAC. Let's do it in the colors that I gave them to you. Angle BAC. Let's do the measure of angle BAC is equal to the measure of angle BAC DCA. And for the red ones, we'll put it in red. The measure of angle DAC is equal to the measure of angle BCA. Forgot to say the measure of angle. Don't want to be wrong. The measure of angle, what did I say, BCA? And that's the definition of alternate interior angles. All right. So I have two angles and I need the included side. So the included side is literally a side that's being shared. We could say that AC is equal to AC, and that's the reflexive property. Whenever you say something is equal to itself, it's always the reflexive property. Now that I used angle, side, angle, I can say that those triangles, and let's make sure we have it in order. Let's do ACD. Triangle ACD is congruent to red, purple, so CAB. And that is ASA. And since these guys are completely congruent, now we could say AD is congruent to BC, boop, and AD is congruent to BC, so that'll be our last step. Let's see if I can fit that in. AB is congruent to DC, comma, AD is congruent to BC, and that is corresponding parts of congruent triangles are congruent. All right? So again, this is one of those proofs where you're proving an actual theorem. Okay, it's not as simple as you saying, well, my book says theorem 6.12b says that parallelograms have opposite sides that are congruent. So can I just do a two-stepper? Technically, yes, but we wanted to show the actual proof of that, and that's what we did. Dunzo. Given AE is equal to EC, congruent, and DE is congruent to EB, I need to prove that ABCD is a parallelogram. So what do I know? I know that you guys are congruent. I know that you guys are congruent. That's it. I need to explain that these are a parallelogram. Well, there's three ways really that you can show that things are a parallelogram, and none of them really have to do with the diagonals. But what they do have to do with are either opposing angles, consecutive angles, or opposing sides. I'm not given a ton of information about angles, consecutive angles, or anything like that. Consecutive angles would be like this whole angle A and that whole angle D. I'm not given any information about those. Okay, I'm also not given any information about opposing angles, which would be like that whole angle D and that whole angle B. So I'm going to do with the sides thing because I'm given a lot of information about the sides. So I'm thinking that since I'm given two, like the way this picture is set up is I have four triangles. I'm given the fact that these two sides are the same, these two sides are the same, these guys cross in the middle, so I can say that these guys are the same. I can say that, what color didn't I use yet? Red. These guys are the same. So if I can use SAS, 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 and SAS and prove that both pairs of triangles are congruent using SAS, then what I can do is I can prove that AD is congruent to BC and AB is congruent to DC. And I could use CPT, CT, CPP, CT, ICP for that one. Once I've done that, I can say this is a parallelogram. Okay? So let me start over. This is the green and blue is the information I'm given. All right? I could use vertical angles to show that the purples are the same and the reds are the same. Now that I have side angle side 4 times, I could say this triangle, the bottom triangle and the top triangle are the same. The left triangle and the right triangle are the same. And since they're the same, step number 5 or whatever, I could say that AD and BC are the same, and I could say that AB and DC are the same, and I could say that corresponding parts of congruent triangles are congruent. Now that I could say, now that I have information saying that opposing sides are congruent, that is using the opposite sides theorem converse to prove that this is a parallelogram. All right, hopefully I explained that well enough. This is, whenever I make a proof, I always make a rough draft off to the side. So there's my rough draft. So let me start out with my given. Always start out with the given, and that's AE is congruent to EC, and DE is congruent to EB given. All right, so I have two pairs of congruent sides of triangles going on here. I also have the fact that, let me use different colors. Let me use the colors that correspond. I also could say that AED, the measure of angle AED, what a shocking angle, and the measure of angle CEB, the measure of angle CEB, if I can write that correctly, they're congruent. Technically, I didn't need that little congruent thing if I'm saying the measure of angle, but I'm not even going to attempt to erase that. The measure of angle AEB is equal to the measure of angle CED. And this is the definition of vertical angles. Now that I said that, I have, like, you know, a side angle side matches up with a side angle side. So I can explain that triangle, and we have to be careful with the order that we put this in. I'm going to go blue angle, blue, purple, green. So AED, the angle or the triangle AED is congruent to CEB in that order. And I can also say that DEC, the triangle, is congruent to BEA. And the reason for that is side angle side postulate. Since these two triangles, the lefty triangle and the righty triangle, are exactly the same, then we can say that AD is congruent to BC. And we can also say, since these triangles are the same, that AB is congruent to DC. And that was corresponding parts of congruent triangles are congruent. Last but not least, now that we have shown that opposing sides are congruent, we can say that ABCD is a parallelogram. And the reason for that was the opposite sides theorem's converse. Theorem converse. Opposite sides theorem converse, which says that if opposite sides of a quadrilateral are congruent, then you have a parallelogram. Okay? So there you have it. This is a way that you could prove that a quadrilateral is a parallelogram. The opposite sides theorem converse. You have opposite angles theorem converse, which is exactly the same thing, but angles instead of sides. And you have the corresponding sides, angles, I give up. The consecutive angles theorem converse. That one. And those are saying, you know, if they're supplementary, then you have a parallelogram. Fun. Given ADB is congruent to CBD, and also that AD, this guy, is congruent to BC, I need to show that ABCD is a parallelogram. So there's many ways that you can do this. And I did a video where I used what's called the opposite sides theorem converse. I'm going to use a different one, and you'll see which one I do. Okay, because the picture is a little bit friendlier than the other one that I did. What I'm going to do is I have sides that are congruent. I have angle and angle that are congruent, and I have a shape that looks like a quadrilateral cut into two triangles. So what I can do is use the fact that DB and DB are the same exact thing, and I could use SAS to say that this triangle and this triangle are congruent. Okay, one more time, I could use SAS to say that the triangles are congruent. I'm just making a rough draft over here. Once I say that SAS are congruent, what I can do, you know what? No, I'm going to do the opposing sides again. I already know that AD and BC are congruent, but since these triangles are congruent, I could say that these sides are congruent by using CPCTC. So I could say that AB is congruent to DC by using the corresponding parts of congruent triangles are congruent theorem. Now that I have that, I could say that this is a parallelogram using the opposite sides theorem converse. I was going to do the opposite angles one because I was like, let's do this angle and this angle, but I briefly forgot that, you know, I need this whole angle 2 and that whole angle 2. And I really don't feel like saying like, all right, well, these angles are also congruent. And if I add these angles, I get these angles and then those are congruent too. I would have to add a few more steps, which I don't feel like doing. I'm a lazy bones. All right, let's write our given first. Angle ADB is congruent to angle CBD. Also, AD is congruent to BC, given. All right. In green here, I can say that side DB is congruent to side DB. And the reason for that is the reflexive property. Whenever you say that something is equal to itself, that's the reflexive property. Now that I have an angle in between two sides, remember the angle has to be in between two sides if you're going to use SAS, but I do have SAS. Now that I have SAS, I can say that triangle, and let's go in order. Let's go from the A and go ADB, triangle ADB is congruent to triangle CBD in that order. And what I did was side angle side, SAS. So since this triangle up on the top left is congruent to that triangle at the bottom right, I could say that AB and DC are the same. So 4 is side AB is congruent to side DC. And that is because congruent parts, corresponding parts of congruent triangles are congruent. Last but not least, these sides are congruent. We were told these sides are congruent. That was part of our given. So opposite sides are congruent. Therefore, ABCD is a parallelogram. And the reason for that is the opposite sides theorem converse. Of course, what the opposite sides theorem converse says is if the opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. If for some reason you forgot that that's called the opposite sides theorem converse because that's just a terrible name, then you could say that since opposite sides of this quadrilateral are congruent, then it is a parallelogram. Okay? So there you have it. One more time where we proved that shape is a parallelogram, and we could do that using opposite sides. We could do it using opposite angles, which I thought I wanted to do, but I didn't want to do. There's a way that you could use consecutive angles. If you could show that this whole angle and that whole angle add up to 180, do the same thing with DC. D plus C is 180, C plus B is 180, and B plus A is 180. Then you have yourselves a quadrilateral that's a parallelogram too. You could do that, but you know, it is possible. Maybe not for this one, but that won't happen often. But yeah, this was probably the easiest way to go. Done. What up, what up? All right, I am looking at a picture of what looks to be a quadrilateral, four-sided figure on a coordinate plane, and my job is to find out if it's a rhombus, a rectangle, a square, or a combination of the three, or none of them. So this is what I need to do. In order for it to be a parallelogram, first off, because all of these fit under the parallelogram umbrella. In order for it to be a parallelogram, opposite sides have to be parallel, which means their slopes have to be the same. So let's first determine that. Let's find the slope of each guy just by doing rise over run. So I'm going to go from J to K, up 1, 2, 3, 4, 5, 6, over 1, 2, 3, 4, 5, 6, 7. So my slope is, what did I say, 6 over 7. That's my slope from J to K. My slope from L to K is up 1, 2, left 1, 2, 3, 4, 5, 6, 7, 8, 9. So up 2, left 9. My LM is up 1, 2, 3, 4, 5, 6, over 1, 2, 3, 4, 5, 6, 7. So that's 6 over 7 again. And I have a feeling this is going to turn out nicely. By the way, you're going to hear my clock say 10 o'clock in a second. 1, 2, over 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So we definitely have a parallelogram here. Now, what makes a rhombus is all four sides have to be the same. This is where it gets annoying. In order for all four sides of it to be the same, we need to use Pythagorean theorem to determine if that side... Now, I know these two sides are the same. 10 a.m. I know these two sides are the same, and these two sides are the same. Well, I mean, these two sides are the same as each other, and these two sides are the same as each other. But are all four sides the same? So let me find out the length of this side right here. If I've just pretended that this is a right triangle, I know the qualities of this right triangle. That's a side of 2, and that's a side of 9. So Pythagorean theorem, and I know I could use point formula or distance formula, but I hate distance formula. So I'm just going to use Pythagorean theorem, which is a squared plus b squared equals c squared. That's a lot friendlier in these cases. I have a side of 2 and 9. So I'm going to do 2 squared plus 9 squared equals c squared. That becomes 4. That becomes 81 equals c squared. Add them up, you get 85. 85 is equal to c squared. Take the square root of both of them, and you get 9 point something, but I'm just going to leave it as a square root of 85 because whatever this is, this has to be the square root of 85 also. So let's do it again. With this, I could draw a triangle knowing very well that this height is 6 and that is 7. So I'm going to do 6 squared plus 7 squared equals c squared. That becomes 36. That becomes 49 equals c squared. Add those two up, and I get 85. No way! Which means these guys are the same length. So if these guys are the same length, that means these all are going to be the same length. It's a rhombus! Is it a rectangle? No! And here's why. If it's a rectangle, then this line has to be perpendicular to that line, which means the slopes have to be negative reciprocals of each other, and they're not. So it's not a rectangle, which means it's not a square. So we have ourselves a rhombus, but we don't have ourselves a rectangle and a square. That's it. Bye. What's crack-a-lackin'? Let's talk about rectangles. Now, we know everything about rectangles. It's a shape that we learned since we were little babies. But what we don't think about is slope and rectangles. I'm being asked to use the slope formula. Even though I have a nice coordinate plane here, I'm not going to use it. We are being asked to use the slope formula to determine if these 4 points make up a rectangle. Now, if it's a rectangle, two sides have to be parallel. Another pair of two sides have to be parallel, which means the slopes of parallel sides are the same. But not only do we need that, we need to determine if they're perpendicular. So what I'm looking for, now perpendicular slopes are negative reciprocals of each other. So this is what I'm looking for. I need two lines that have the same slope. I need two lines that have a different same slope. And are those different slopes negative reciprocals of each other? If they are, I have a rectangle. So let's just go in order. We have JK. So JK, here's my slope formula. Let me write it once up here, once alone. I think I have enough space. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to use the slope formula 4 times. I'm going to do JK first. And I will not say JK because I'm being dead serious. The slope for JK is going to be, let's mark these x1, y1, x2, y2. So my slope is going to be negative 6 minus 2 over negative 8 minus negative 10. We're going to do some mental gymnastics here, so as not to make this video a 20-minute video. Negative 6 minus 2 is negative 8. Negative 8, oh, a double negative. So we've got negative 8 plus 10 is regular 2. JK is negative 4. The slope of JK is negative 4. It's 1. One of them's done. So we need KL. So let me, where's my eraser? There you are. Let me erase this guy. I need KL. Do a different color. We'll call you X1, Y1. We'll call you X2, Y2. I'm going to be KL. M equals negative 3 minus negative 6 over 5 minus negative 8 we've got negative 3 plus 6, which is regular 3, and 5 plus 8, which is 13. So I'm done. Why am I done? These two are different. And so if they're different, then they would have to be negative reciprocals of each other. Last time I checked, 3 over 13 ain't no negative reciprocal of -4. So is this a rectangle? No. Again, the only way that this would have worked is we needed to get two slopes that were the same, two different slopes that were the same as each other, and those guys have to be negative reciprocals of each other because they form perpendicular lines, because it's a rectangle. That didn't happen because there's no negative reciprocal action happening here. We are done, we are done, we are done, done, done. I don't need to go any further. So that wasn't so bad. It really wasn't. I had fun though. All right. Bye. Solve for x, the figure is a trapezoid. All right, what I have here is I have a median, okay? The median is basically exactly what it sounds like. It's the middle part of a trapezoid or a parallelogram or whatever it is that you're dealing with, whatever quadrilateral that you're dealing with. So if this is a trapezoid, we have two parallel sides. Doesn't mean that they're parallel angles or they're congruent. They're just parallel. But this is the median, which means it's directly in the middle. The formula to find the median is 1/2 times the sum of base sub 1 plus base sub 2. So if we were to call UM, and it doesn't matter which one your base sub 1 is or base sub 2 is, so we'll call you base sub 1, base sub 2. If I were to use this information to solve for x, I would say that the median, m, negative x plus 21, 9 plus m, equals 1/2 of base sub 1, which I called 17, plus base sub 2, which I called 11. So PEMDAS says let's do everything inside the parentheses first. So 1/2 of 17 plus 11 is 1/2 of 28. Negative x plus 21. 1/2 of 28 is 14. Now I have a two-step equation. Let's subtract 21 from both sides, minus 21. Negative x equals negative 7. And if negative x equals negative 7, then positive x equals positive 7. So there's our guy. And if we wanted to check our work, negative 7 plus 21 is 14. So this length would be 14, and 14 happens to be completely in between 11 and 17. It's the average, essentially. And that's what the median gives us, right in the middle. Ooh, let's talk about mid-segments. Now, mid-segments have that prefix mid, and mid means middle. And in math and geometry specifically, when you see mid, you're thinking average. Like the midpoint is the average of 2 points. You add them up, you divide by 2, bada bing. Mid-segment is no different. This guy is going to be this guy plus this guy divided by 2. Or better yet, the mid-segment, 15, and I'll put it right here, is going to be 1/2 of the two bases added together. So base number 1 is going to be x, base number 2 is going to be 18.2, and then from here it's just an ugly algebra problem. Let me distribute the half. So I have 15 equals half of x. I probably could have just multiplied both sides by 2, but it's too late. I stuck with it. Half of x is half of x. Half of 18.9 is 9.1. Now I subtract 9.1 from both sides. That gets me 5.9. 5.9 equals half of an x. Multiply both sides by the reciprocal of a half, which is 2. And x is going to be what looks like 11.8 after I multiply 5.9 times 2. That seems about right. 15 seems to be smack dab in the middle of 11.8 and 18.2. Smack dab in the middle. That's it. That's all you have to do. And this time we had to work a little bit backwards. But you know what? I had so much fun working backwards. And I had so much fun learning with you. Like and subscribe. You won't. They never do. Bye. Solve for x, the figure is a trapezoid. Actually, let's be a little bit more specific. See how these guys are congruent? This figure is an isosceles trapezoid. And the rule for isosceles trapezoids is not only do they bisect each other, but the diagonals are actually congruent. If these weren't isosceles trapezoids, they wouldn't be congruent. But in this case, these two, EC and FD, are congruent. So since it gives us EC and FD, I could set those guys equal to each other. So EC is 20, FD is 5x minus 10, and I have a regular two-step equation. Okay, 5x minus 10, let's add 10 to both sides, add 10 to both sides, cross you out. 20 plus 10 is 30. Drop down the equal sign, drop down the 5x. In order to get x all by itself, we divide everything from 5. And let's flip it around. I like my x on the left. 30 divided by 5 is 6. So x equals 6. And if I wanted to check my work, I could do 5 times 6 is 30. And 30 minus 10 is 20, just like EC is already. So there you go. Isosceles trapezoid because these two guys are congruent, which means the diagonals are also congruent. Bada bing! The figure is a trapezoid. Specifically, this is an isosceles trapezoid. I should have put those markings there. But when you have isosceles trapezoids, there's some news. Angles next to each other that are not on the same side, or I guess these would be considered bases. So angles that are on different bases that are next to each other add up to 180 degrees. So what I can do is I could say 6x minus 22, this angle right here, plus 8x plus 34, angle R, both of those add up to 180 degrees. So I can combine like terms, 6x, 8x, 14x, minus 22 and positive 34 is 12. That's going to equal 180. And I have myself a two-step equation. Okay, let's get rid of this 12 first by subtracting 12 from both sides. Subtract 12 from both sides. 4x equals 168. 14x, not 4x. But would that change things? Divide everything by 14. Divide everything by 14. And x is going to equal 12. Circle that and call it a day, right? Wrong. It's not asking for x. It's asking for the measure of angle R. And the measure of angle R is 8x plus 34. X is 12. So the measure of angle R is 8 times 12 plus 34. 8 times 12 is 96. 96 plus 34 is 130. So the measure of angle R is 130 degrees. Now, if you're like, oh, I don't believe you, then what you could do is you can plug in 12 to x up here and get 6 times 12, which is 72. 72 minus 22 is 50. So if this is 50 and that's 130, then those guys add up to 180 degrees, which is what I originally said it would. Okay? So that's how you add adjacent angles of a trapezoid if they're on different bases. Find x. All right, what do we have here? We have, a rhombus. This side is congruent to that side, which means these two guys are equal to each other. So let's set that up. 8 equals x plus 1, a one-step equation, minus 1, and x equals 7. Very straightforward, very simple problem. That's how it's done. Find x. All right, what do we have here? We have, a rhombus. This side is congruent to that side, which means these two guys are equal to each other. So let's set that up. 8 equals x plus 1, a one-step equation, minus 1, and x equals 7. Very straightforward, very simple problem. That's how it's done. Find x. What we have here is we have a rhombus. There's a couple ways that we can approach this, but what I see is it gives me a rhombus that's cut in half right here. And by cutting a rhombus in half, you are creating an isosceles triangle. Why does that matter? Well, because if you are 8x minus 3, then you are also 8x minus 3. You're 106, and these are 3 angles of a triangle. So the 3 angles of a triangle add up to 180 degrees. So 8x minus 3 plus another 8x minus 3 plus 106 equals 180. Now, if you're wondering, well, couldn't I have just done 2 times parentheses 8x minus 3? Sure. But, I set it up this way, and I'm not stopping. I'm not erasing a thing. So I have 8x, that's 16x. We're combining like terms. I have negative 3, another negative 3, which is negative 6, and 106, which is a perfect 100. That equals 180. Now I have a 2-step equation. First, subtract 100 from both sides. I think I can handle the math here. 180 minus 100 is 80. 16x is on the left still. In order to get x all by itself, we divide 16 from both sides. And 80 divided by 16 is 5. We're being asked to find x, nothing more, so x is 5. And if you wanted to double check your work by plugging in 5 for x, and you get 40 minus 3 and 40 minus 3, and then all that up, you get 180, but I'm gonna leave it like that. Okay? Dunzo. Find the measure of RST. All right, where is RST? RST. Ooh, okay. What I have here is I have a rhombus cut in half. Now, what I know is when you take a rhombus and cut in half, you get yourself an isosceles triangle right here. Why does that matter? Because if you're 5x minus 5, then you are also 5x minus 5 because isosceles triangles have the same exact base angle right here. So I can set up an equation where this angle plus this angle plus this angle equals 180 degrees. So let's do that. 5x minus 5 plus 5x minus 5 plus 5x plus 10 equals 180. Good news. -5, -5, and positive 10 all cancel each other out. -5 plus -5 is -10. -10 plus 10 is 0. Nothing. 5x plus 5x plus 5x is 15x. And now I have a one-step equation. All I have to do is divide both sides by 15. And x equals 12. Done? Nope. because what I have to do is find the measure of angle RST. What I know is this guy is 5x minus 5. X is 12. So that guy is 5 times 12 minus 5, which is 60 minus 5, which is 55 degrees. So this guy is 55 degrees. Now, since this is a rhombus and this diagonal cut this guy in half, that means both of these are 55 degrees. And in order to find the whole thing, I take 55 and add it to itself, meaning that the measure of angle RST, which was that whole thing, is 55 plus 55, which is 110 degrees. So this one required you to think outside the box a little bit. Or should I say, think outside the rhombus. Ah, yes. Yes, sir. Vroom, 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 all aboard the rhombus. I'm going to talk about rhombuses today. What is a rhombus? Well, a rhombus is a parallelogram, but all the sides are exactly the same. Now, since it's a parallelogram, we know that the diagonals bisect each other. We also know that if it's a rhombus, when they do bisect each other, they create 90-degree angles. That's a new rhombus fact. And also a fun rhombus fact is that the diagonals bisect the angles that they go through. So that's the thing about a rhombus. You got, and of course, opposite sides are parallel. Opposite sides are congruent. There's like 5, 6, 7 different things that you can talk about when it comes to a rhombus here. What do I care about in this particular problem? Well, let's see what we have. We have AP, which is that guy, is 3x minus 1. And then we have PC. Uh-oh, someone called the PC police. I'm just kidding. Please don't. That guy. So all we really care about is the fact that it's a rhombus, which means it's a parallelogram, which means diagonals bisect each other. So I'm just going to set these guys equal to each other and use that to find the whole thing. All right, I can do this. Let me use my purple marker to say that AP is 3x minus 1. Purple and red are going to be equal to each other, so I'm going to set them equal to each other. I'm just going to solve for x here. I'm going to subtract x from both sides, subtract x from both sides. That gives me 2x minus 1 equals 9. Now it's a two-stepper. Add 1, cross u out. 2x equals 10. Now it's a one-stepper. Divide by 2, and x is equal to 5. Am I done? Nope! Because my job is to find AC. There's several ways that I could do that. I could find AP and multiply it to 2. I can find PC and multiply it to 2. I could find AP and PC, find out that they're exactly the same, and then add them to each other. It doesn't matter. I'm just going to choose PC because it looks easier. And what I'm going to do is I'm going to replace that x with 5. So I get 5 plus 9, which is 14. So PC over here is 14, which means without having to do anything fancy, you're 14. And so the whole diagonal is going to be 14 plus 14, which is my age at 28. I'm sorry, that's not true. My age in a few years. Bye. Find the missing measure. What do we have? We have these two guys are congruent. These two guys are congruent. Oh, adjacent sides are congruent. This is a kite. You can imagine putting a line here and a line here and pretending there's a string and a couple bows and you have yourself a kite. Now, what's important about this is these two guys are what's called the vertex angles, which means F and H are the non-vertex angles. So why do we care about the non-vertex angles? Well, because they're congruent. So if my job is to find out what F is, I know H is the same. So if I call you X, then I can call you X. Now, how does that help me? Right now, it doesn't. But what I do know is this is also a quadrilateral. And quadrilaterals add up to 360 degrees. So 66 plus X plus 70 plus X is 360. So let's set that up. 66 plus X plus 70 plus X is 360 degrees. Combined like terms, 66 plus 77 is 136. X plus X is two of them, so 2X. And now I have myself a regular old two-step equation. If we subtract 136 from both sides, minus 136, 2X is going to equal 224. Divide both sides by 2, and X equals 112. Now, we want to find out the measure of angle F. We called the measure of angle F X. So, the measure of angle F is X, which means it's 112 degrees. All right, so again, we add ourselves a kite. These two guys, the non-congruent angles are going to be congruent. They're called the non-vertex angles. And so we just set it up equal to 360 and got it. Dunzo. ME equals 20. Me is 20. I wish. What do I know about this shape? Oh, these two guys are the same, and these two guys are the same. We have a kite. The diagonals of a kite bisect each other, which means you guys are the same. Doesn't help me here. You guys are the same. That does help me here because it says that ME is 20. So if ME is 20, that means EK is 20. And MK, Mortal Kombat, is found by adding 20 plus 20. According to this calculator that I have right over here, MK is 40. Find X. What do I have? I have these two guys are congruent and these two guys are congruent. We have a kite. Now, what information am I given? I'm given 50 degrees right here and 8x plus 2. And these guys are created by taking CE, which is technically a diagonal of this kite. What do we know about the diagonals of kites? Well, the diagonals of kites bisect the angle that it goes through. And if things bisect angles, that means this angle and this angle are exactly the same measure. So I can say 8x plus 2 equals 50 because they're the same. So now I just start out with the two-step equation, minus 2, drop down the 8x. 8x equals 48. In order to get x all by itself, divide both sides by 8, divide both sides by 8, and x is 6. And that's all we had to do here was just find x. I don't have to plug it into anything. If I wanted to check my work and do 8 times 6, which is 48, 48 plus 2 is 50, it looks like I did it right. But yeah, the diagonals of kites bisect the angle. Pretty nice. Find the measure of angle Z. All right, there's Z. So what I have is I have the fact that 7x minus 4 5x plus 20, they oppose each other, and I have 105. So this problem is not near as simple as I wish it was. This is what I know. These two sides are congruent. These two sides are congruent. This is a kite because the sides are next to each other, not opposing each other. Now, when you have a kite, okay, the angles in between the non-congruent sides are called non-vertex angles. And these angles are equal to each other. So this is what I'm going to do. I'm going to find x by setting these two equal to each other. Once I have x, that allows me to find out the measure of both of these angles. Does that arrive me at my answer yet? No. My job is to find that angle. So once I find out this angle will be the same. I have 105, and I would have 3 angles in a quadrilateral, and the 4 angles in a quadrilateral add up to 360. So I have to start out by setting these guys equal to each other first, finding out what these are, and then I can finally take care of z. So 7x minus 4 equals 5x plus 20. I have x on both sides of the equal sign, so let's subtract 5x from both sides. Let's subtract 5x from both sides. 7x minus 5x is 2x. Drop down the minus 4. Drop down the equal sign. Drop down the 20. I can add 4 to both sides, like that. 2x equals 24. Divide both sides by 2. And x equals 12. Again, that's helpful because now that I have x, I can find out both of these angles. Now, they're both going to be the same, so it's not like I have to plug in 12 into both of these and solve them separately. No, if I just find the easier one, like this guy, and do 5 times 12, right? 5 times 12 plus 20, that gets me 60 plus 20. This is 80. So you are now 80, and you are also 80 because you two guys were congruent. Finally, I can figure out what z is. So I will actually call this z, and what I know is that this is a quadrilateral. And this angle plus this angle plus this angle plus this angle is going to equal 360 degrees. So 80 plus 80 plus 105 plus z is 360 degrees. If I combine like terms, 80 and 80 is 160. 160 and 105 is 265. 265 plus z equals 360. Subtract 265 from both sides. Subtract 265 from both sides. Z equals 95. So you're 95, which means after all of this, I can finally say that the measure of angle z is 95 degrees. So this one required a little bit of extra thought. But these are the types of problems that I love. You have to kind of look at what you have, figure out what you have to do, and sometimes it's not as simple as doing one mathematical process. In this case, we had to do 3. But it was great, and it was fun. Find the area of this triangle right here. Looking at this triangle, it doesn't really look like it's as obvious as it is. But if I were to take this triangle and spin it around and make it look like this, where now I could say that this whole thing is 9 yards and this is 6.4 yards, it's a little more obvious what I have. The area of a triangle is 1/2 of base times height. Now, the height is always going to be a perpendicular line going straight up and down to a base. Here, I don't really see the height because you were like, oh, the height should be up from here to here. But it doesn't matter. Any way you spin a triangle, you can get your height. So by taking my triangle and kind of laying it flat so that the 9 yards is flat on the ground, I can see the 6.4 as going up and down. So you're my base and you're my height. So I could say that my area is 1/2 of my base, which is 9, times my height, which is 6.4. Okay, 1/2 of 9 times 6.4 is 28.8. Now, before I circle that and be very happy, we're talking about the area here. Okay, the area is always given in units squared. So I'm going to make sure I say square yards for this guy right here. Okay, depending on your teacher, you might have a teacher that's like, oh, I only care about the number. I really don't care about this part. But you really should say that the area is whatever units squared. Feet squared, yards squared, square inches, square meters, whatever it is. Okay? So that's how you find the area of a triangle. Sometimes you have to spin it around in your mind, which I did. Find the area of this trapezoid right here. All right, the area of a trapezoid is given to us by the formula 1/2 times the height, parentheses, base sub 1 plus base sub 2. This trapezoid is kind of lying flat already, and it gives us the height right there, and it's 5. Which one's base 1, which one's base 2? Doesn't matter. Doesn't matter at all. Okay? So the area of this guy is going to be 1/2 of 5 times base sub 1, which I called 6, plus base sub 2, which I called 3. All right, so 1/2 of 5 times 9. This is probably one that I can do without the use of a calculator. 1/2 of 45 is going to be 22.5. Yeah. Now, before you circle that and call it a day, it's asking for area. And whenever you're being asked for the area, you should always include the units, but square them. Okay, so this is miles. So we're going to say 22.5 square miles. All right, don't ever just say 22.5. Don't say 22.5 miles. It's 22.5 square units. Okay? So we're done. Trapezoid. Write the name of each polygon. Now, polygons get their names by how many sides they have. So let's count the sides and name them. 1 side, 2 side, 3 side, 4 side, 5 side, 6 side, 7 sides. A 7-sided figure is called a heptagon. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is a decagon. 10. Decagon. Now, I'm marking the sides so I don't accidentally overcount. So these little marks doesn't mean necessarily that they're the same. I mean, in this case, they look like they are. I'll put little check marks now. 1, 2, 3, 4, 5, 6, 7, 8, 9 is a nonagon. And last but not least, this weird-looking creature at the end here is 1, 2, 3, 4, 5, 6. 6 sides, hexagon. So when you do problems like these, when you're naming things and you're just asked to name the polygon, you don't care if it's regular, which means all the sides are exactly the same, or not, unless they want you to be specific. Technically, this is a regular heptagon because all the sides are the same. I technically wasn't told that, but it's a little obvious. This is not regular. These are not regular. But again, you know, all we had to do was name them, and so I did. State if each polygon is concave or convex. The difference between a concave or a convex is if you have all of the angles where the interior angles are less than 180 degrees, it's convex. Now, I know something is concave when it looks like part of the outside caves in. So this guy is concave. Does this cave in a little bit? Yep, concave. Does this cave in at all? Nope, convex. That's the difference between the two. That's it. State if each polygon is regular or not. A polygon is regular if all the sides are congruent and all of the interior angles are congruent. So you look like you are all congruent, and you look like you're all congruent. So I would say, yeah, that's regular. You, no. I don't even have to mark anything. That's obviously not a regular shape. Okay? So regular, not regular, dunzo. Find the interior angle sum. The interior angle sum is a fancy way of saying, if I were to add up all of these angles, how many angles live inside the whole thing? Well, there's a formula for the interior angle sum. S equals 180 times the number of sides minus 2. N here stands for the number of sides. So what I do is I count up how many sides I have. I substitute N with that number, do a little bit of PEMDAS, and I have my answer. So you are 1, 2, 3, 4, 5 sides. So N is going to be 5. So using the formula for this guy, I have S equals 180 times 5 minus 2. In other words, 180 times 3 is 540. So the angles of a pentagon, which is what I have, add up to 540 degrees. How many sides do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So N equals 12 in this case. So the sum of all the angles is going to be 180 times 12 minus 2. So the sum is going to equal 180 times 10, which is 1,800 degrees total. Okay? So there you have it, interior angle sum of a polygon. Pretty simple formula to use. Dunzo. All right. Today we're going to talk about the interior angle sum and how we can use that to find the missing angles of any convex polygon. So what do I got here? I got myself a pentagon, and I need to find the measure of each interior angle of this pentagon. Well, before I do anything, I need to find out what all of these angles add up to. And for that, I'm going to use the interior angle sum. It's a pretty simple formula. You just take 180, multiply that to the number of sides minus 2. So this is a pentagon. It has 5 sides. I'm going to do 180 times 5 in parentheses minus 2. So that's the same thing according to PEMDAS as 180 times 3. And that's going to give me 540. Now, every time I add a side onto a triangle, or any shape for that matter, I mean, a triangle is 180, and anytime I add a side, I'm adding another 180. So you have 180 for triangles, 360s for quadrilaterals, 540s for pentagons, 720, 900, 1080, so on and so forth. But that takes away the fun of using this formula. And boy, was that fun. But the fun doesn't have to stop there. My job is to find the missing angle measurement for each angle. Well, I don't know what they are, but what I do know is they add up to 540. So I'm going to take all 5 of these guys and add them up and set that equal to 540. So 3x plus 14 on the bottom left plus 2x plus 142 plus 2x again plus 3x plus 14. Now, if you're wondering, sir, why aren't you including the parentheses? Well, if you add a parentheses, the parentheses no longer become its own group. You are now part of the whole. You're part of the crew. You're part of the gang. And that whole thing adds up to 540. So what do we have on the left here? Well, we have a whole lot of combining like terms, so I'm going to do just that. I have 3x plus 2x, which is 5x, plus 2x, which is 7x, plus 3x again, which is 10x. What a sweet combination. 10x is a type of sugar. Now what? Now I'm going to add regular old numbers there. I'm going to add these constants. 14 plus 142 is 156, plus 14 again is 170. So I have plus 170 equals 540. What do I have here? I just have a good old-fashioned two-stepper. So I'm going to subtract 170 from both sides because that's the number that's floating around. When I do that, that's a 7. When I do that, I get 10x is equal to 370. Is x all by itself? No. 10's being multiplied, so let's divide both sides by 10. And x is going to end up equaling a nice, not nice, 37. Wow. One day my age will be 37. One day, many years from now. I'm done, right? No! My job is to find each individual angle. So I have to take that 37 and apply it to these 4 guys. Why not you? Well, I already have that angle measurement. So for 2x and 2x, what I do is x is 37 now. I do 2 times 37, and 2 times 37 is 74. So this guy is 74 degrees. This guy is 74 degrees. Those are done. How do I find these bottom 2?
Please come to the main office at this time. Ms. O'Connell, please come to the main office. Thank you.
How do I find these bottom 2? Well, I'm going to take my 37 and I'm going to plug it into x and do a little bit of simplifying. 3 times 37 plus 14. 3 times 37 is 111, I believe it is. And adding 14 to that gives me 125. So you're 125. You're 125. We're going to attach degrees symbols to all of these. Now, if I add all of these up, I should get 540. So let's double check. 125 plus 125 plus 74 plus 74 plus 142. Don't forget to like and subscribe.
Something went wrong.
Great.
Please try again.
No, I'm hoping this is right. And getting a quick look, what is that? That's 250 plus these 2 would be 148. 250 plus 148 is 398 plus 142 is 540. I did it! I did it. All right. That was fun. Interior angle sum complete. Bye. Find the measure of one interior angle. We are given a regular 1, 2, 3, 4, 5, 6, 7 octagon. So we are given a regular octagon where all of the angles are exactly the same. So this is what we have to do first. In order to find one of the angle measures, I have to find the angle measures of this whole thing, which requires us to use the interior angle sum formula that guy right there. 180 times the number of sides minus 2. So S is going to equal 180 times 8 total sides minus 2. 180 times 6 is 1080. Like the snowboarding game for Nintendo 64. Now this is the degrees of everything. If all of these add up to 180 degrees, that means 1, 2, 3, 4, 5, 6, 8 of the same exact measurement. 8 of the same angle. So I will say 8A for angle equals 1080 degrees. Divide both sides by 8, and you end up with 135, which means each interior angle is 135 degrees. And the only reason why we were able to do it this method is because this is a regular polygon. If it's not a regular polygon, that's going to require a little bit of extra thought. But since this was regular, it made life a whole lot easier. So we're done. Find the measure of one interior angle. We are given a regular 1, 2, 3, 4, 5, 6, 7 octagon. So we are given a regular octagon where all of the angles are exactly the same. So this is what we have to do first. In order to find one of the angle measures, I have to find the angle measures of this whole thing, which requires us to use the interior angle sum formula, that guy right there. 180 times the number of sides minus 2. So S is going to equal 180 times 8 total sides minus 2. 180 times 6 is 1080. Like the snowboarding game for Nintendo 64. Now this is the degrees of everything. If all of these add up to 180 degrees, that means 1, 2, 3, 4, 5, 6, 8 of the same exact measurement. 8 of the same angle. So I will say 8A for angle equals 1080 degrees. Divide both sides by 8, and you end up with 135, which means each interior angle is 135 degrees. And the only reason why we were able to do it this method is because this is a regular polygon. If it's not a regular polygon, that's going to require a little bit of extra thought. But since this was regular, it made life a whole lot easier. So we're done. Find the measure of one exterior angle. All right, there's a rule that says the exterior angles, and if you're like, what's an exterior angle? If you were to take each side and keep going with the side, the exterior angle is the measure there. So if I were to do this all the way around, it's asking me, what's the measure of one of these? For every single convex polygon, the exterior angle sum is always 360 degrees. So what I have to do here is I have to find out how many angles there are. So the way I do that is find out how many sides there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 sides, which means there's 9 exterior angles. So I will call an exterior angle X for exterior. And since there's 9 exterior angles and they all add up to 360, I'll say 9x equals 360. Divide both sides by 9, and x equals 40. So each exterior angle is 40 degrees. And we can kind of see that. I know we're not supposed to look at a picture and estimate, but we could see that if I were to put a bunch of these, they would each be 40. And if I were to glue them together, I would get 360 degrees. So that's my guy.
Well.
Let's talk about exterior angles. What's an exterior angle when it comes to polygons? See how this polygon has all these sides that just keep going? Well, these angles created outside a polygon are called exterior angles. And it just so happens that when you have a polygon and a bunch of exterior angles, all of those exterior angles add up to 360 degrees, no matter how many sides you have in the polygon. Whether it's a triangle, whether it's a nonagon, all of them add up to 360 degrees no matter what, says the theorem. So what we're going to do is we're going to take that guy, that guy, that guy, that guy, that guy. We're going to add them all up, set it equal to 360, and that's it. So I'm starting with the top one, 2x minus 5. I don't need the parentheses there because if I'm just adding a bunch of parentheses, the parentheses are no longer useless. The group becomes part of the whole. Plus 3x plus 10. What else? On the bottom, we have plus 6x minus 5. And then the bottom right, we have 2x. So I'm going to add 2x using my mouse, which is why this is slow. And we have 5x, and that should do it. Okay. And all of the exterior angles, no matter what, for any polygon, no matter the size, shape, whatever, can always add up to 360 degrees. So what I'm going to do is I'm going to combine some like terms. We got 2x, we got 3x, which is 5x, plus 6x, which is 11x, plus 2x, 13, plus 5x. Is we have 18 x's. Then we can combine negative 5 plus 10, which is regular 5, but minus 5 again. We have no constant floating around. Oh, isn't life just easy? And 18, what a super convenient number. Because what I do now is I divide both sides by that 18, and 360 divided by 18 is a perfect 20. All I have to do here is find x. That's it. So technically I'm done the problem. If I wanted to go one step further and like find each angle measurement, I would say, all right, well, fine. 2 times 20 is 40. That angle is 40, and 5 times 20 is 100. And 2 times 20 is 40 minus 5. This angle is 35. So on and so forth. All right, that's exterior angle stuff for you for polynomials. Polygons, not polynomials. Got Algebra 2 on the mind. Whew. Oh, Algebra 2 on the mind. Bye. Find the area of the regular polygon. All right, so the area of a regular polygon is found by multiplying 1/2 times the perimeter times the apothem. Now, if you're thinking, isn't apothem like a vermin that lives outside at night and is really gross looking? No, that's a possum. We're being asked to find apothem. So I like that joke. That's a good joke. What is an apothem? An apothem is basically a side bisector that's going to be perpendicular to that side and hits the center. So this right here is my apothem. And what I have is one of the side lengths. One of the side lengths is 12. All right, well, in order to find the perimeter, I have the apothem is 14.5. That's the apothem. In order to find the perimeter, I have the fact that you're 12. There's one side, two sides, 3, 4, 5, 6, 7, 8. So the perimeter is going to be 8 times 12. So the area is found by multiplying 1/2 to 8 times 12 times 14.5. All right, so I'm going to go off to the side here and pretend like I'm not going to plug this into a calculator. And I did this all in my head, and I ended up getting 69.6. Nice. Now, do I have any units? No. If I had units, I would say square units. So I'm just going to put square units, square U anyway. I'm allowed to do that because it's area. But that's how you find the area of a regular polygon. So, yeah, fun. Apothem. Find the area of the regular polygon. Well, what do I have? I have a 1, 2, 3, 4, 5, 6-sided shape. Okay? I know that the area of a regular polygon is 1/2 times the perimeter times the apothem. Now, this is the apothem, so I know that you're going to be 5√3. Gross. Perimeter. I don't know what the perimeter is, but I do know that there are 6 sides and each side is 10. So the perimeter is going to be 6 times 10, and the area is going to be 1/2 times that. So I should be able to do this without a calculator. 1/2 times 6 is 3. So I have 3 times 10 times 5√3. 3 times 10 is 30. So 30 times 5√3 is going to be 150√3. I don't have any units, so I could say units squared. All right, so that's how you do it. √3. Can't forget √3. Ooh, that was a close one. Ooh.